Hi students, in this video we see all the 5-mark questions and the expected 5-mark questions from the first chapter. So July 2022 5-mark questions: solve the system of linear equations by Cramer's rule. The given linear equations are 3x plus 3y minus z is equal to 11. Second equation 2x minus y plus 2z is equal to 9. And the third equation is 4x plus 3y plus 2z is equal to 25. We are asked to use the Cramer's rule here. So first we write what is delta. Delta is equal to the coefficient of x, y and z in the first linear equation. We write in the first row, that is 3, 3 minus 1. The second equation 2 minus 1, 2. Third equation, the coefficients are 4, 3 and 2. Expanding the determinant, we get 3 into minus 2 minus 6 minus 3 into 4 minus 8 minus 1 into 6 plus 4. Now this is equal to 3 into minus 8 minus 3 into minus 4 minus 1 into 10, which is equal to minus 24 plus 12 minus 10, which is equal to minus 22. Now delta 1. Now delta 1 will be is equal to replacing the first column by the constants. We get delta 1, where delta 1 will be is equal to 11, 9 and 25 first column. Second column elements remains the same. Coefficient of z, that is the third column, coefficients elements remains the same. Now expanding the determinant, this is equal to 11 into minus 2 minus 6. Next element minus 3 into, taking the minor, we get 9 into 2 is 18 minus 25 into 2, which is equal to 50. Minus 1 into, multiplying the minor elements, 9 into 3 is 27, minus of minus 25 gives us plus 25, which is equal to 11 into minus 8 minus 3 into minus 32 minus 1 into 52, which is equal to minus 88 plus 96 minus 52, which is equal to minus 44. Now we have found what is delta, delta 1. Next we find what is delta 2. Delta 2, the x coefficients remains the same. X coefficients are 3, 2 and 4. And in the place of the y coefficients, we take the constant elements. So we get here constants are 11, 9 and 25 in the three equations. The coefficients of z remains the same, 2 and 2. Now expanding the determinant, this is equal to 3 into 9 into 2, 18 minus 25 into 2, 50 minus 11 into minor of 11 will give us 2 into 2 is 4 minus 4 into 2 is 8 minus 1 into 2, 2 into 25 is 50 minus 9 into 4 is 36. Now this is equal to 3 into 18 minus 50 gives us minus 32 minus 11 into minus 4 minus 1 into 14, which is equal to minus 96 plus 44 minus 14, which is equal to minus 66. Now we find what is delta 3. Delta 3, the coefficient of x and y remains the same. So 3, 2 and 4. The coefficients of y are 3, minus 1 and 3. And the constant elements are 11, 9 and 25. Now we expand delta 3, where delta 3 is equal to 3 into minus 25 minus 27 minus 3 into 50 minus 36 plus 11 into 6 minus 4. So now this gives us, this is equal to 3 into minus 52 minus 3 into 14 plus 11 into 3 into 2 is 6 minus of minus 4 gives us, this is 6 plus 4. So this is 10. Now this is equal to 6 plus 4 is 10. Now 3 into 52 minus 156. minus the next element is 14 into 3, 42 plus 110, which is equal to minus 88. So now we have found what is delta. Minus 22, delta 1 minus 44, delta 2 is minus 66, and delta 3 is minus 88. Now delta is not equal to 0, therefore we can use the Cramer's rule. Cramer's rule where x is equal to delta 1 by delta. Delta 1 we got minus 44 divided by delta value is minus 22, which gives us 2. Now next y value will be is equal to delta 2 by delta, which is equal to delta 2 is minus 66, delta is minus 22. So we get minus 66 by minus 22, which is equal to 3. Next z value is equal to delta 3 by delta, which is equal to delta 3 is minus 88 and delta is minus 22, and therefore we get the value as 4, and therefore we write find the value of k for which the given three equations have no solution, unique solution, infinitely many solution. So this question is from exercise 1.6. This is an public question and is also an expected question. So we use the rank method to find the values of k and find for what values of k the given equations have no solution, unique solution, and infinitely many solutions. We write first what are the given equations. The given equations are kx minus 2y plus z is equal to 1, x minus 2ky plus z is equal to minus 2, and the third equation is x minus 2y plus kz is equal to 1. Now I write the given three equations in matrix form. What is the matrix form of the given equation? The coefficient elements in the first matrix, A matrix, given to us k minus 2, 1, 1 minus 2k, 1, and the third equation coefficient of x is 1, y is minus 2, and z is equal to k. Now the unknown matrix x, y, and z are the unknown variables, which is equal to 1, minus 2, and 1. The matrices of the form Ax is equal to B. In the rank method, we write the augment matrix AB matrix, which is equal to A minus 2, 1. That is the first matrix. A matrix 1 minus 2k, 1, 1 minus 2 and k. Along with this, we combine the B matrix, that is 1 minus 2 and 1. Now we are going to bring this matrix in the echelon form. So now this is equivalent to, it is always easy for us to simplify when the first entry becomes 1 here. So what we are going to do is we are going to interchange R1 and R3, keeping R2 the same. So when we interchange R1 and R3, R1 is 1 minus 2 K1. Second row remains as it is, 1 minus 2. And the third row is K minus 2, 1 and 1. So we have interchanged R1 and R2. Next, our aim is to bring this A21 element to 0, A31 and A32 element to 0. These three elements must be brought to 0. So the next transformation what we are going to do is this is equivalent to the first row is as it is. It remains as it is. The second row we are going to make the transformation where R2 tends to R2 minus R1. So 1 minus 1 gives us 0, minus 2k minus of minus 2. So minus 2k plus 2, 1 minus k, next element, minus 2 minus 1 gives us minus 3 here. The next transformation, R3, I'm going to bring this element to 0. So R3 tends to R3 minus k into R1. So Rk minus k gives us 0. Here minus 2 and minus of minus 2k. So that gives us minus 2 plus 2k. Next 1 minus k squared. Next element is 1 minus k. So we have brought A21 elements to 0 and A31 element to 0 now. The next transformation, we are going to add R2 and R3. So first row remains as it is. I'm going to change R3 here. So second row minus 2k plus 2, 1 minus k, minus 3 remains as it is. R3 mixing the transformation from R3 plus R2. So the elements are 0. Adding these two elements, minus 2 plus 2, 0, minus 2k plus 2k, this element becomes 0. Now adding these two elements, 1 plus 1 gives us 2 minus k minus k squared. Then so R3, I'm going to add R3 and R2. So the next element will be minus 2 minus k. Next transformation, there is no transformation. We are going to, it is already in echelon form. So we are going to split the quadratic polynomial. This is equivalent to 1 minus 2 k 1, second row 0 minus 2k plus 2, 1 minus k minus 3, 0, 0. This 2 minus k squared can be written as minus of k squared plus k minus 2. Split into factors, this can be written as minus of k plus 2 into k minus 1. Multiplying this minus sign to any one out to this bracket, we can write it as k plus 2 into 1 minus k. So we are splitting this factor as k plus 2 into 1 minus k. Now this element is minus of 2 plus k. Now it is easy for us to find the solution. First case, what is the first case here? No solution. When do we get no solution? Only if rank of A is not equal to rank of AB, we get no solution. So what is the value k takes here? When k takes the value 1, then k takes the value 1, the element k is, this element becomes 0. K is equal to 1, we get the element minus of 2 plus 1, we get minus 3 here. So the rank of A becomes the 2, rank of AB becomes 3, and therefore there will be no solution. So when I take the value for k is equal to 1, what happens here? The rank of A becomes is equal to 3, rank of A becomes 2. This element becomes 0 here. So rank of A is 2, rank of AB becomes 3, and therefore we say rank of A is not equal to rank of AB, and therefore we get no solution when k value is equal to 2, k is equal to 1. Next, second step, unique solution. Unique solution, when do we get the unique solution? Only when rank of A is equal to rank of AB, we get the unique solution. So in order to get the unique solution, here what we do, we take the value for k is not equal to 1 and k is not equal to 2. K is not equal to minus 2. When we take k is equal to minus 2, this element becomes 0, this element also becomes 0. Next, when k is equal to, we take the, this is important, when k is not equal to 1 and k is not equal to minus 2, we get rank of. So here when this is not equal to 0, this is not equal to 0 in the sense k is not equal to minus 2, k is not equal to 1, we get the rank of A and AB to be the same. Rank of AB becomes is equal to 3, and therefore we get the unique solution. Next, in coming to infinitely many solution, we get infinitely many solution only when the rank of A and rank of AB is less than or equal, less than 3. Either rank is 1 or 2, then we get infinitely many solution. So that is possible only when these two elements are 0. So when does these two elements become 0? Only when we take k value is equal to minus 2. We get the number of non-zero rows becomes is equal to 2 here. Therefore, here the third condition, when k takes the value k is equal to minus 2, the rank of A is equal to rank of AB becomes is equal to 2. We get infinitely many solution. Moving on to the next term, the values of lambda and mu. Find the values of lambda and mu when so that we get no solution, unique solution, and infinitely many solution. Here we first write what are the given equations. Given 2x plus 3y plus 5z is equal to 9. The second equation is 7x plus 3y minus 5z is equal to 8. And the third equation is 2x plus 3y plus lambda z is equal to mu. We write first the matrix form of the given equations. The matrix form, the first coefficient matrix is 2, 3, 5 from the first equation. Second equation coefficient 7, 3 minus 5. Third equation 2, 3 and lambda. Unknown variables are x, y and z, and the constant matrices 9, 8 and mu. Now the matrices of the form Ax is equal to B. We write the augment matrix now. The augment matrix is AB matrix, AB, which is equal to A matrix 2, 3, 5, 7, 3 minus 5, 2, 3 lambda, and B matrix 9, 8 and mu. Now we are going to transform and bring it to the echelon form. So what are we going to do here? This is equivalent to, I'm going to change R2 to multiply R2 with 2 and R1 with the 7. So here we write R2 is equal to 2 times of R2 minus 1. So we get first row remains as it is. We change R2 now. So we get this element becomes 0. Next element 2 times of R2. 3 into 2 gives us 6 minus 21 is minus 15. Minus 5 into 2, 10. 10 minus 35 gives us minus 10 minus 35 gives us minus 45. 8 into 2, 16. Minus 7 into 9 gives us minus 47. Similarly, we make the transformation with R3. Multiply R3 with, we need not multiply since the first element is 1 here. We just subtract R1 and R3. Subtract R1 and R3. So we get R3 minus R1 gives us 0 here. 3 minus 3 gives us 0. Now this element will be lambda minus 5 and the next element will be mu minus 9. Now this matrix is in echelon form. The equivalent matrix is in echelon form. So to get no solution, when do we get no solution? No solution only when if rank of A is not equal to rank of AB. So when lambda takes the value 5 and mu is not equal to 9. When this number is equal to 0 and this is not equal to 0, we get the rank of A becomes is equal to 2 and rank of AB becomes 3, and therefore we say rank of A is not equal to rank of AB and there is no solution. Next case is for unique solution. We find the values of lambda and mu. When do we get unique solution? Unique solution we get only when this lambda minus 5 is not equal to 0, mu minus 9 is not equal to 0, which implies when lambda is not equal to 5 and mu is not equal to 9, we get here unique solution. The rank of A becomes 3 and rank of AB also becomes 3, and therefore we say we get the solution is the system of equations are consistent having unique solution. Infinitely many solution. Here we say that mu is not equal to 9. Either we can tell mu is not equal to 9 or we can say mu belongs to any real number, belongs to R. Then we say whatever number we give, not only 9, any number we give this element is not equal to 0. Either it can be 0 or not equal to 0. When this element is not equal to 0, the rank automatically becomes 3 for A and AB here. Next, many solutions. So lambda is equal to 5 and mu is equal to 9. The rank of A is equal to rank of AB becomes is equal to 2, and therefore we get infinitely many solutions. The next question, September 2020, 5-mark question. Test for consistency the following system of equations by rank method. So 3 equations are given. We write the given equations 2x plus 2y plus z is equal to 5. The next equation x minus y plus z is equal to 1. And the third equation 3x plus y plus 2z is equal to 4. What is the procedure? We write the matrix form first. The matrix form, coefficient matrix 2, 2, 1, 1 minus 1, 1, 3, 1, 2. Coefficient of x, y, and z in the 3 equations. Next, the unknown variables x, y, z is equal to the constants, that is 5, 1, and 4. Now, the equation is of the form Ax is equal to b, where x can AB matrix, augment matrix can be written as this is equal to A matrix 2, 2, 1, 1 minus 1, 1, 3, 1, 2. And B matrix 5, 1, and 4. We are going to bring this to the echelon form. So first what we do, it will be easy for us when the first entry is a non-zero, the row echelon form is first entry is non-zero. R2n element becomes 0, R21, A21, A31, and A32 becomes is equal to 0. So first let me bring the first element to 1 by interchanging R1 and R2. So we interchange R1 and R2. So 1 minus 1, 1, 1, 2, 2, 1, 5, 3, 1, 2, 4. Now we make the transformation, which is very simple now. Now R1 remains the same. We make the transformation with R2 to R2 minus 2 times of R1, which gives us 2 minus 2, 0. 2 minus of minus 2. 2 plus 2 gives us 4. Next element is minus 1. Then 5 minus 2 gives us 3. Next, similarly, R3, we make the transformation to R3 minus 3 times of R1. 3 minus 3 gives us 0. 1 plus 3 gives us 4. Next element is minus 1. Next is R3 minus 3 R1. So we get 4 minus 3. The next transformation, we want to bring this element to 0. So now this is equivalent to first two rows remains as it is. Minus 1, 3. Now we are going to transform again R3 to R3, 0, 0. So this element is 0. 1 minus 3 gives us minus 2. Now we see the rank of A is equal to 2. Rank of AB becomes 3. Rank of AB is equal to 3. And therefore we say test for consistency. We have to test what the system has, what type of solution. So here we say the system is inconsistent, having no solution since the ranks are not equal. The system is inconsistent, having no solution. Another important expected 5-mark question. Determine the values of lambda for which the given system of equations have unique solution and non-trivial solution. So first we write what are the given equations here. The equations are x plus y plus 3z is equal to 0. The next equation is 4x plus 3y plus lambda z is equal to 0. And the third equation is 2x plus y plus 2z is equal to 0. Now we write the 3 equations in the matrix form, where the matrix form is the first equation coefficients are 1, 1, 3. Second equation 4, 3 and lambda. Third equation coefficients 2, 1 and 2. The variables are x, y and z, which is equal to the constants 0, 0 and 0. This is a system of augment matrix, AB matrix, which is equal to 1, 1, 3, 0. 4, 3, lambda 0. Next 2, 1, 2, 0. Now we bring this matrix to the equivalent matrix to the R2 and R3. So R2 and R3, let me interchange first. First row remains as it is. The third row becomes the second row. Second row becomes the third row here. We have interchanged to simplify. So this is equivalent to, now R2 can be transformed to R2 minus of 2 times of R1 and R3 to R3 minus of 4 times of R1, where R1 elements remains the same. So 2 minus 2 gives 0, 1 minus 2 is minus 1, 2 minus 6 gives us minus 4. Next element is 0. R3 4 minus 4 0, 3 minus 4 gives us minus 1, lambda minus 12. The next element will be 0. Now we are going to find the 0. So this is equivalent to 1 1 3 0, 0 minus 1 minus 4 0. The next transformation is R3 tends to R3 minus R2. So we get here 0, 0, lambda minus 8 and 0. When lambda is equal to 8, when this element is equal to 8, the lambda minus 8 becomes, this element becomes 0, and therefore the system of equations have non-trivial solution. It has a non-trivial solution only when lambda is equal to 8 and this element becomes 0. The system has when lambda is not equal to 8. This is not equal to 8 and not equal to 0. Then the number of non-zero rows becomes 3 and the system has trivial solution. Only for equation we give the name trivial and the non-trivial solution. So we say it has not trivial solution.